Hey everyone, we're going to pick up where we left off in class. So this is, we did problem number 11, so we're going to move on to 21 and we'll work through that solution. Okay, so 21 gives us two vectors. Vector A is I plus 2j minus 3k. You can think of that as the vector 1, 2, negative 3. And vector B is the vector -2, -1, 5. I prefer to write it in that notation, so we're just going to go straight to that. So the first question is find vector A plus B. That's just adding the components. So that's -1, 1, and 2. And next asks us to do 2A plus 3B. So that's just a linear combination. So 2 of A would be 2, 3 of B would be -6, so that gives us first component of -4. 2 of A is 4, and 3, so 4 plus -3 gives us 1. And then we go with 2, so -6 plus 15, that gives us 9. So we've got -4, 1, 9. Our next question is the magnitude of A. So magnitude is square root of each component squared and then summed. So we've got 1 squared plus 2 squared plus -3 squared. 9 plus 4 plus 1 gives us root 14 is our answer to that one. And then the magnitude of A minus B. So let's first find what A minus B is. So that would be the vector 3, 3, -8. And then magnitude would be square root of 9 plus 64, or square root of 82. And that's 21. Okay, next up is 26. So for that one, we've got find a vector that has the same direction as -2, 4, 2, but has a length of 6. So let's make a unit vector out of this one, and then we will multiply that by 6, so that has a length of 6. So to make a unit vector, let's find the magnitude. So square root of 4 plus 16 plus 4 gives us root 24, or 2 root 6. So our unit vector would be -2 over 2 root 6, 4 over 2 root 6, and 2 over 2 root 6. That's a unit vector in the same direction as the original. Let's simplify that to be -1 over root 6, 2 over root 6, and 1 over root 6. Then to have that vector be a length 6, we'll multiply this vector by 6. So that means that our answer is -6 over root 6, 12 over root 6, and 6 over root 6. Okay, and don't worry about rationalizing the denominator. That's not important to me. Okay, 31 and then 34. Okay, so 31 says, a quarterback throws a football with an angle of elevation of 40 degrees and a speed of 60 feet per second. Find the horizontal and vertical components of the velocity vector. Shouldn't be too new to you, even though we didn't do one just like this in class. We're taking a vector and just finding its components in the x and y direction. So magnitude is 60 feet per second, and the angle of elevation is 40. So this component is 60 cosine 40, and this component is 60 sine 40. And we will grab those on the calculator real quick. 60 cosine 40. Okay, so 45.96. And then 60 sine 40. So we'll do that one. 60 sine 40. And that gives us 38.57. So 38.57. There we go. Okay, and then we get one more. So 34. And that one is the magnitude of a velocity vector is speed. Suppose that a wind is blowing from a direction of north 45 degrees west at a speed of 50 kilometers per hour. This means that the direction from which the wind blows is 45 degrees west of the northerly direction. A pilot is steering a plane in the direction of north 60 degrees east at an airspeed of 250 kilometers per hour. The true course or track of the plane is the direction of the resultant of the velocity vectors of the plane and the wind. The ground speed of the plane is the magnitude of the resultant. Find the true course and ground speed of the plane. Okay, so let's draw a couple things going on here. So if we're going north, 45 degrees west. So north and then 45 degrees west would be this. So I'm going to make these components, I'm going to put it in kind of polar notation, right? This is like 50 for the magnitude and 135 for the angle. And then the pilot is steering the plane. I'll do that one in red. North, 60 degrees east. So north and then 60 degrees east. So these are not drawn to scale, obviously, but 250 and then this would be 30 degrees. So let's just check that I have those right. So north, 45 degrees west, that's correct. And then north, 60 degrees east, that's correct. And we need to basically add these. The resultant means add them. But we can't add them unless we know their components. So we're going to convert the first vector to rectangular form by going 50 cosine 135 and 50 sine 135. And the second component, or the second vector similarly. Okay, and then we can add them then from there, and we'll have components in rectangular form. Okay, let's do it. Okay, so 50 times the cosine of 135 plus 250 times the cosine of 30. That's our x coordinate. I'm going to store that as x. And we'll do the same. 50 sine 135 plus 250 sine 30. Our y coordinate. So let's store that as y. And then the question asks for the ground speed. Yeah. Okay. True course and ground speed. Okay. So if we have our x and y coordinates, we're in the first quadrant. You can sort of think about if the plane is intending to go at that heading of, or at that angle of 30 degrees, then, and the wind is only blowing a little bit, the magnitude is a lot shorter than what I drew it, we're still going to be pointing in the first quadrant. So we'll take inverse tangent of y over x to get our angle. So that's our true course. The true course would be 41.5 degrees. Or you could write that in a way like this. You could say east 41.5 degrees north. You could do it like that, or you could reference it from north as well. You could say north, and then what would that be? 90 minus 48.5. So north 48.5 degrees east would be another option. And then for magnitude, we'll do the square root of x squared plus y squared. So 241.9 kilometers per hour. Okay, hopefully that's helpful. We will answer more questions in class. See you then.